sequences are often discussed in multiple math courses and are crucial in understanding many different math contexts, both inside and outside the context of discrete math. In this video, we'll introduce arithmetic sequences and discuss some properties of arithmetic sequences. Hey everyone, real quick, I just want to mention that this video is a part of a whole course that I made. You can find a link to this entire course in the description below, and make sure to click on that subscribe button. Let's first define arithmetic sequences. If the terms of a sequence differ by a constant, we say the sequence is arithmetic. If the initial term a0 of the sequence is a and the common difference is d, then we have the recursive definition as an equals an minus 1 plus your common difference, with a naught equal to a, and the closed formula would be an equals a plus d times n. So for the recursive definition, we need to specify a naught. Then we need to express an in terms of an minus 1. If we call the first term a, then a naught equals a. For the recurrence relation, by the definition of an arithmetic sequence, the difference between successive terms is some constant, say d. So in that instance, an equals an minus minus 1, which I'll write here. The difference between each successive term here is d. This is just another way of writing that right there. In other words, a naught equals a and an equals an minus 1 plus d. To find the closed formula, first let's write out the sequence in general. So in this sequence, we start with a, and then we have specifically a plus d. And then our next term is a plus d, which is just a plus 2 times d. And the next one would be a plus 3 times d, and then a plus 4 times d, and so forth. And so for that reason, the closed formula is a plus n times d, which is exactly d times n, which is where we get this closed formula. So we see that to find the nth term, we need to start with a and then add d a bunch of times. In fact, add it n times. That's why an equals a plus d times n. Let's do an example together. Once we work with numbers, this will all make more sense. So let's find recursive definitions and closed formulas for the arithmetic sequences below. Assume the first term listed is a naught. Okay, so for this first one, we should check that these sequences really are arithmetic by taking differences of successive terms. Doing so will reveal the common difference d, which is what we want. So for number 1, we're going to do 5 minus 2, which is 3. That's the difference here, plus 3. And then 8 minus 5 is 3. 11 minus 8 is 3. 14 minus 11 is 3. So in general, an minus 1 is 3, or the recursive definition is an equals an minus 1 plus that common difference 3. And then for the closed formula, well, we know that an equals, it's the first term plus d a total of n times. But in this case, d and a are defined as 2 plus 3 times n, which is 2 plus 3n. Okay, so now for number 2, we have to find the common difference. In this instance, and let me erase this so we can start over again. In this instance, it looks like the numbers are decreasing, so the common difference is going to be negative. In particular, 43 minus 50 is negative 7. 36 minus 43 is negative 7. 29 minus 36 is negative 7. It looks like d equals negative 7. And in particular, we see that the difference of each successive term is 7, or an equals an minus 1 there, plus 7 with, and I forgot to mention last time, a naught was 2 for that example there. In this example, a naught is 50. And so for the closed formula, we know that an equals a plus dn, but we know what a and d are. A is the initial term 50 here, plus d, which is negative 7 times n. And so we start with 50 and we're adding negative 7 n times. And so that's the closed formula right there, and that's the recursive definition right there for number 2. Anyways, thanks everyone, and I'll see you in the next lecture.